pictures. I'm just saying. So whatever you do with the pictures, if you put them on Flickr, tag them with SwiftConf, and if you don't want to put them on social network or whatever, just give me the pictures directly. Most of those pictures are really awesome. This is the reason why we also don't have an official photograph, because we know we have every time 5 unofficial photographs. And usually I'm more for the unofficials. And the other thing is, before we start, is reminding that for those who stay when we are done around 4 p.m., just hang around with us. I haven't decided exactly what we do, but what we'll probably do is we will go together to the center of Cologne and find some places where we can spend another couple of hours, because I know some of you will stay here for another couple of days. And if somebody doesn't want to come with us, but rather visit something or whatever, I won't take it personally. So that's also perfectly cool. All right, let's move on to IBM, which is kind of a success story of SwiftConf, I have to say. Because the main reason why IBM decided to be a sponsor this year was because Ayan last year, I think, liked the conference a lot. Cool. So we kept in touch, and like I was saying yesterday, they actually wrote me so the way I do is I don't really go outside and ask every single company in the world. I do ask a few, but I'm not very active on this. But lucky enough, I have some companies who come with me, like IBM and Lodom, and ask, can I sponsor? And then we at one point decided that it was going to be interesting to move or pivot from the server side to the serverless thing, which is something pretty new, actually. I'm just going to turn your mic because you realize otherwise you're going to have to speak with your hands. And so this is when the team told me that you were going to be the one to speak about it.
Yeah, I am.
So we're excited. Ladies and gentlemen, give a round of applause for James.
So hello everybody, my name's James Thomas, and I'm a developer advocate for IBM working in our cloud division. I'm going to be talking to you today about a kind of new way to build and run Swift microservices, Swift backend, Swift APIs in the cloud without having to set up or manage any infrastructure to be able to do this. Right now, having to provision virtual machines, not having to create containers, not having to worry about configuring Linux and application servers and middleware and all that kind of stuff. And this might sound kind of impossible, right? Serverless Swift without servers. Because surely if you want to run your Swift in the cloud, you have to set up and manage the environments to be able to do this. But I'm going to show you a new approach using what they called serverless cloud platforms that allow you to do just that. And in the kind of most of this talk, second half of this talk, going to be doing a live demonstration of creating some live Swift APIs using one of these platforms to give you the kind of skills and techniques to go away and do this yourself. Now, at this point, as well as thinking this sounds kind of impossible, right? Serverless Swift. You might also think that it sounds unnecessary. You might think that, I like my servers, I like my environments, I've got them set up and configured just how I want them, and I can kind of log in over SSH and copy my Swift file over to deploy my application. Right? Why would you want to take my servers away from me? Well, the reason is this. Servers kill your productivity. And you might not realize it yet, especially if you're new to back-end development, but trust me, it's true. And I think by the end of this talk, you're going to agree with me. You're going to want to go back to your office, gather up all of those servers, set them on fire, and be free forever of the tyranny of looking after infrastructure. Right? I think servers are one of the worst things that's ever happened to software developers. So why am I so convinced, right, that servers kill your productivity? Well, you're all Swift developers. Most of you seem to be doing iOS development, and you're probably very excited about doing back-end development in Swift. Now I can write my back-end in the same language as my front-ends. This is a big improvement. Don't need to go and learn an extra stack. So you'll quickly build some APIs, some microservices, and then you want to deploy it. So you think, I know what I have to do. Now I'll just get myself a server. I put my Swift on the server. Everything's going to be wonderful. I don't have to think about anything anymore. Well, unfortunately, that's not going to be true, because what you will soon find out, if you're new to back-end development, is that suddenly you have all of these extra tasks to do, right? If you're starting with VMs and you need to install and manage the environment yourself, get Linux on there and the middleware and the database, all the services, once it's up and running, you have to keep it updated, right? I have to put new kernel patches on, if security bugs, middleware, all that kind of stuff I have to manage. You have to monitor it when it's running in production, make sure it's healthy, it's not constantly crashing. You need to think about security, right? Is it backed up? Is it encrypted? Does it use, long passwords for SSH and that kind of stuff? And then you also need to become some kind of wizard because you need to predict the future. Because when you provision those environments, you have to decide today how much capacity you need, how much CPU, disk space, RAM, how big a file system for load that only occurs in the future. And it's very, very hard to predict, how much load you might get in 6 months' time to make sure you have kind of enough capacity. And then hopefully, if your application's successful, which is what you want, you're going to have even more traffic. And so the way we have to think about scaling normally is provisioning more servers. So suddenly you have a cluster, and then you have to think about replication and scaling and fallover. And suddenly you're going to find yourself spending all of your time managing these environments, right? I think as backend developers, it can often feel like you're held hostage by your infrastructure, right? You want to spend your time in Xcode writing lovely Swift and actually find yourself like hunched over some Linux terminal trying to fix some kernel issue that is constantly driving you around the bend. And this is not really what I want to do, especially with Swift developers, right? I don't really become some kind of magic Linux infrastructure engineer. Now, you might also think at this point, right, well, hold on, James, wasn't the cloud supposed to fix this? I've always been told that all I have to do is put my backend, put my microservices in the cloud, and all of my infrastructure challenges just can magically go away. And I think in the technology industry, we kind of sell cloud as this utopian vision, right? The cloud allows you to treat infrastructure as a utility, right? You just do like electricity, or gas or water, where you just provision as much as you want on demand, elastically, use it to do your processing, and when you're done, you just kind of throw it away, and you only pay for the resources that you use. But for many of us who are kind of more familiar with building kind of back-end services in the cloud today, I think that the way we use cloud and existing cloud platforms are a long way away from what you think of as a traditional utility model for computing. So let's think about a traditional utility that you're all familiar with, right? Let's think about electricity, your electricity provider, and compare that to how many of us do development in the cloud today. So when you get connected and your house needs electricity and you ring up your provider, do they ask you at the weekends, once it's all set up, can you go down and maintain the power station? Right? Do they say, we'll plug the power station together, but once it's up and running, you just have to go down and check it's all right? And you think, no, I don't maintain my power station, right? I just use electricity and then I just pay for what I use. I don't have to worry about any of the maintenance. But again, with many cloud systems, things like infrastructure as a service, even containers, right? Maybe the servers are virtualized. You don't have to physically plug them in, but you still have to maintain the environments when they're up and running. Okay, so does your utility provider ask you to do capacity planning up front? When you ring up to get electricity, do they say, well, how much are you going to need in 6 months' time? So that we can make sure that the substation near your house is big enough to generate that capacity. You just kind of say, no, I just use as much as I need, and I'm just going to kind of pay you for it. But again, with cloud systems today, you have to decide up front how much memory and CPU and disk space you need for your virtual service to be able to power your application, even if actually you're not really sure how much load you're going to have. And then finally, does your utility provider, do they charge you for unused capacity? Do they say, actually, we're generating loads of electricity at the moment, so if you don't use it, you still have to pay for it? And again, no, I don't think anyone pays for excess electricity that your provider generates. But again, with traditional cloud infrastructure systems, you provision your servers up front, you decide how much memory and CPU, and then if you never get any load, right, you don't get any traffic or applications idle, actually you have to pay for all that capacity, whether you're kind of using it or not. You provision it up front, and then you pay for it regardless of whether you really need it. And again, hopefully I can kind of talk about why, I think that this is not really a utility model for computing, right? It doesn't really fulfill those factors we've talked about. So what can we do, right? Unfortunately, you're probably all really excited about building microservices in Swift and deploying them to the cloud, and now you're very depressed because you're wondering about all these extra tasks you have to take care of that's going to kind of kill your productivity. Well, fortunately for you all, don't be too sad for too long, because I'm going to introduce you to what I think is a much better way to build and run Swift microservices in the cloud using something they call serverless cloud platforms. And serverless cloud platforms are really built as, I think, the next generation cloud computing service or cloud computing platform. I think that for the first time allows you to treat computing infrastructure as a pure utility model. So let me ask at this point, who's ever heard of this term serverless cloud platform before? Oh, so some of you, okay, so quite a good number. Things like, have anyone used one yet? Things like AWS Lambda, OpenWhisk, Azure Functions, all that kind of stuff. Okay, so some of you. But if this term was completely new to you, as well as thinking it's ridiculous like everyone, of course there's going to be servers in there, you might go to Wikipedia and you're kind of reading about it and you're like, okay, so it says that, serverless cloud platforms, they run your code in response to events. It will say it manages your compute resources, and it says allows you to build event-driven applications. And you're probably like, at this point, scratch your head and think, well, like, that doesn't sound very revolutionary to me, right? It sounds like every press release for every cloud platform there's ever been. They all say this kind of stuff, right? But serverless cloud platforms are different, and they're different for a couple of reasons. The first is that they shrink the unit of deployment. So rather than having to deploy your application as a kind of monolithic VM image with all your services and middleware and libraries and stuff baked in, or even as some kind of monolithic deployment package with, again, loads of XML configuration or something, serverless cloud platforms allow you to literally push up the raw source code for functions you want to execute into the platform, and whenever an API request comes in, the server will kind of invoke your code on demand. So rather than thinking about your application or the services, you can literally just focus on individual microservices and push them straight up, and then they get executed on demand. And another difference is that your code, when it's pushed up, it doesn't sit there waiting idle for requests to come in. The platform starts it in milliseconds to process every individual request. So what happens when written a Swift function, right? You pushed it up to the Service Cloud platform, it's processing a request, and another request comes in parallel. Well, with serverless cloud platforms, scaling is the platform's responsibility, right? The platform just spins up a new environment, injects your code to process every request that comes in parallel. So now, rather than me as a developer having to think about scaling in terms of, well, how much capacity, how much disk space and memory does a physical server need to cope with 10,000 requests a second, right? Now that's the platform's responsibility. Scaling is going to be handled by the platform. I'm just going to write my code and not worry about it. And as well as serverless cloud platforms, they kind of call this horizontal scaling, scaling up horizontally. They also scale down because, as I said, your code is only actually running when it's processing requests. So if you've got no traffic to your app, no requests to process, no work to do, none of your microservices are actually executing, kind of asleep waiting to be invoked on demand. And that's really, really important when we think about the pricing model. So serverless cloud platforms, like all cloud platforms today, are pay-as-you-go, right? You pay for the kind of resources that you use. But remember that I said that you're only using resources with serverless cloud platforms when you're processing requests. So for the first time ever, you don't have to pay for idle time within your application. And I think that's a really, really underappreciated fact of serverless cloud platforms. And it can lead to some dramatic cost savings in your kind of monthly cloud bill. I've seen many use cases. People talk about this a lot. You can go and read lots of blog case studies of people talking about reduction in their monthly cloud bill of 80, 90% because now they don't have to pay for kind of any of that idle time. Okay, so enough talking about serverless cloud platforms. I'm kind of waving my hands around. Let's kind of show you some code, right? Let's show you how easy it is to get started and give you the skills and techniques to go away and use one of these to build Swift microservices in the cloud. Now, the first thing you will need is a serverless provider. And today, there's kind of many, right? Serverless as a technology kind of started only 3 years ago when Amazon came out with a new service for their cloud called Lambda back in August 2014 at their conference. And it got really popular with developers, and it kind of grew, usage of it got really popular. And then last year, I think, is the year that serverless really, really took off in the developer space, because one of the ways this manifested itself is that all the other big cloud providers came out with their own competing solutions. They said, this is a really neat way to build microservices of cloud. We're going to come out with our own kind of platforms as well. So serverless is not just an Amazon thing anymore, right? Whoever your cloud provider, I pretty much guarantee you they have some kind of serverless offering for you to be able to play with, right? IBM has one it's now called Cloud Functions, which is based on an open source platform called APACHE OpenWhisk. Amazon has Lambda. Microsoft have one called Azure Functions. Google Cloud have one called Google Cloud Functions. You can see they all have almost identical names. So now you have lots of different choices. It's not just one monoculture of a vendor. And the one we're going to be looking at today is called Apache OpenWhisk. And this was IBM's kind of offering that we announced about 18 months ago now. And when we did that, we open sourced the whole platform, we donated it to Apache, and it's going through that whole incubation process at the moment. So it's not really an IBM platform, it's kind of an open source platform. And recently, we've seen some other companies kind of pick this up. So Adobe have been involved from the start. Adobe are building some kind of service offering based on it. And then a couple of months ago, Red Hat announced that they are going to adopt it. So they are deprecating their own platform they were building, and they're kind of picking up Apache OpenWhisk. So it's getting some kind of traction, which is nice to see in the kind of open source community outside of IBM. So if you are evaluating, okay, so which service, I've got a dozen serverless providers to choose from, which one is going to be best for me? I think there's a couple of good reasons to look at OpenWhisk. The first is that it's open source, right? So the entire platform is open source. You can go to GitHub and read the Scala code if you're really interested to see how it works. The team continues to develop in the open. You can raise pull requests, issues, all that kind of good stuff. And the reason why I think it's important to use open source cloud platforms, I think all developers who build on the cloud today have some existential fear that what happens if they turn the service off, or they deprecate it, or they make it really expensive, right? Or they kick me off the platform. Remember what happened to things like Parse.com and how people were very sad about that. So we think by open sourcing the core components of our cloud platform, it means that you're not so locked in as a kind of user, right? You can run the platform locally, you can deploy it yourself, you can go and use another hosted provider. And OpenWhisk as a platform is completely open source. And you can actually run the whole thing locally in a VM if you're kind of playing around with it, which is quite neat. But actually, the best thing about OpenWhisk for everyone in this room is the runtime support. So if you look across all the big service providers, there's some very, very common runtimes and some which are kind of more provider specific. So all of them basically support Node.js kind of out of the box, right? It's just like the first class serverless cloud platform language. Python is also pretty popular as well, so multiple versions of Python. Java, there's a little bit on some of them. But again, for everyone in this room, the best thing about OpenWhisk is that it supports Swift natively kind of out of the box. So you can literally push up raw, uncompiled Swift functions straight into the platform and have them executed on demand, which is really, really nice. And the way that IBM did this is because IBM's been heavily involved in Swift development. It was just kind of a natural fit for us to get Swift into the platform. So it means that you, as mobile developers, right now, you can go and build serverless functions using the same language. And at the moment, it supports Swift 3.1 as the kind of runtime. Apache OpenWhisk is the only platform at the moment that natively supports Swift out of the box. So some of the others, you can run the binaries, but you have to do some magic shims, and it's not such a nice experience. Another important thing to consider that Apache OpenWhisk gives you is the ability to customize your runtime. So you can actually, if you decide you want to use Swift 4 on the platform, you don't want to wait for the project to update it, you can actually push up a Docker image with whatever runtime you want and run it on the platform. So you can use newer versions of Swift, older versions, or actually you can pretty much these days run anything you want that runs in a Docker image. So we've got a platform that we want to use. We're going to use OpenWhisk for the reasons that I've just talked about. The next thing is you need some Swift code, right? Some Swift microservices to run on the platform. Maybe some Swift code that looks a little bit like this. But the question people have, especially if you're new to serverless development, as they call it, is, okay, so you told me that I just take my code once it's finished and I push it into the platform. But how does the platform know what to do with it when the kind of API request comes in? How does it know what kind of thing to invoke and how to pass the parameters in? Well, with serverless cloud platforms, right, for any runtime, it's always the same. You have to add a particular function to your source code, and that gets called as the entry point. So every time an API request comes in, it's going to call this particular function, passing in the object, and then expecting you to return an object. And this is what it looks like for Swift. Right, so you could have this mycode.swift file. It could be massive. It could be like 1,000 lines long, loads of functions, use third-party libraries and stuff. And all you need to do is add a function with this particular type. Right, so a function called main takes a name parameter called args, which is takes a string any dictionary, returns string any, and then you can just write your Swift code in between. And when you return the dictionary, it gets serialized back out to JSON as the kind of response from the request. So when you've written some Swift functions, right, added this particular interface, which is kind of entry point, and you push it into the platform, OpenWhisk creates what's called an action, right? So an action is the name I'm going to use, or we use in OpenWhisk world for your sleeping microservice waiting to be invoked on demand. So let's have a look at doing that now. Let me take some Swift code from my development environment for a laptop and push it up to OpenWhisk and show you how easy it is to kind of start invoking serverless functions in the cloud. So let me come out and then mirror my screens. Okay. Now, when I'm demoing the cloud, it requires good internet, so you always have to pray to the demo gods before you do this, so that they're kind to you. Okay, so let's start from my let's start from the browser, and I can make that a little bit bigger. So, as I said, Apache OpenWhisk is, it's open source, so you can go and just download it and run it locally. You could deploy it yourself. But really, I think for most people, the point is to go and use a hosted provider so they take care of kind of everything for you. And so I'm just going to be using the one that's available on IBM's cloud. You can just sign up for a free account. You get a very generous free tier. You can just kind of get going. But you could use Red Hat or Adobe or any of the others. So once you've signed up for an account with your serverless provider, the next thing you need some way to get code from your laptop into the platform. And the way they generally all do this is that there is a little CLI you can download. So there's a little command line utility you install that then allows you to create service functions and pass the source code, and it's going to create your microservices in the cloud. And you can see here there's a CLI available for every runtime, and you have to authenticate, right? You have to give it your username and password and all that kind of stuff. But then you're kind of ready to go. So if I go to, let me make this a bit bigger. Okay, can you see that? Okay. So if I type WSK Whisk, this is the CLI that I'm going to use to interact with the cloud platform. And I've already authenticated and set up the endpoint and all that kind of stuff. So let's go through, I think of this as like the hello world example, right? First Swift serverless function. So I have some Swift code here. I think it's called hello.swift. You can see it's a super simple Swift function, right? So obviously it matches the interface that OpenWhisk expects. Function main takes a dictionary, returns a dictionary. And essentially what it does is it just gives you a greeting, right? It says, hello, James, hello, Sally, depending on whether you give it an event parameter, which comes in from the dictionary. Otherwise, it just says kind of hello, stranger. So this is literally the hello world example. So if I want to create a new serverless function in OpenWhisk, you just say whisk action create. You give it a name, hello, Swift. You give it the path to the code. It's going to load my source code to OpenWhisk. And if I list my actions, you will see I've already got some deployed. But now I've got one called Hello Swift. Tells me it's using Swift 3 runtime. OK. So now I can check out. I can say whisk action invoke hello Swift. And hopefully it's going to instantiate the environment somewhere. It's going to put my Swift code and it's going to compile it. It's going to execute it, and it's going to give me the result back serialized out as JSON, right? So there's the result of my code being executed somewhere on some server, but I don't have to think or touch or manage it. And I can call this again. I could call this like 1,000 times in parallel, and it's just going to work, right? I can use different parameters. So now I've got this serverless function that I can call, and I don't really have to worry or think about the infrastructure that it's running on. So that's like a very, very simple, it's like a hello world example, right? Not a particularly useful API to have a kind of greeting service. So let's look at something that I think is maybe a bit more realistic. So imagine you are a retailer, right? You're building your client is a retailer, so you're building native iOS app for someone who has kind of a catalog you can buy stuff through. And they decide they want to integrate Bitcoins into their application. So they want you to be able to pay at checkout in Bitcoin. Now, Bitcoin as a currency obviously fluctuates quite a lot, so you don't want to hard code the Bitcoin values in because they change day to day. So what you want is an API or an endpoint you can call during the checkout process where you're going to pass in currency in an amount. It's going to give you back the equivalent amount in Bitcoins. And you can write this as a Swift function very, very easily. So if I go back to this directory and show you the source code, it's called conversion. So I'll quickly walk you through the code, but it's not hugely what we're interested in. So I've got a function called main. So this is going to be the entry point of my serverless function. It's going to look for two parameters, currency and amount, in the dictionary that comes in, and then it's going to call current Bitcoin prices. And essentially, all this function does is that it uses Katura to go to Coinbase, which is an external Bitcoin wallet, get the current spot prices of the currency exchange, and it's going to pass the JSON that comes back, and then do a tiny bit of maths, obviously, to calculate how much the equivalent of dollars or euros is in Bitcoin. So let's just create it. Let's say whisk action create Bitcoin, give it conversion.swift. And now I can say whisk action invoke. So invoke Bitcoin. So now I need to pass in some parameters, right? I need to see an amount, like thousands, and then currency, US dollars, and hopefully if everything is working, it's going to give me back the amount of $1,000 US dollars in Bitcoin, which you can see is not a lot of Bitcoin at the moment. Bitcoin's very expensive. And you can call this again, right? So I can say, okay, what's that in euros or sterling? And I can say, all right, what's like a million currency? And it just kind of works, right? I don't have to just think about it. I've just got this endpoint I can call, which is really, really neat. So once you have created your serverless functions on OpenWhisk, right? How can you integrate them into your applications that you can call them kind of programmatically through some kind of API? And OpenWhisk has a couple of different ways to be able to do this, depending on your kind of requirements. The first is through they call it a platform API. So the whole platform has a very public, well-documented Swagger docs and that kind of stuff. Platform API that gives you endpoints to be able to do things like create serverless functions, to be able to invoke them, to be able to get the results of your computation. And this is what you can actually use to invoke your functions kind of programmatically. You can just send a HTTP request to the platform endpoint with your developer credentials to authenticate you, and it's going to invoke your code and give the results back. And what you'll note, well, what you didn't realize is when I'm using the command line, when I type whisk action create, whisk action invoke, all it's actually doing is making calls to those that HTTP endpoint. So you can obviously do this from kind of any Swift mobile application. And there's also, if you're using Swift, there's a nice client library for OpenWhisk. So rather than you having to manually construct the HTTP headers and the authentication, all that kind of stuff, you can just use the client library, which is an external package, and it kind of takes care of it for you. You just go like Swift invoke, give it a name. Now, when you're using the platform API, you have to, all your requests have to be authenticated with your developer credentials, right? It's tied to your account. It has kind of full control over your kind of serverless function environment. And often when you're building kind of serverless functions, you want to create public APIs or public endpoints that people can talk to, obviously without exposing your developer credentials to the world. And so OpenWhisk actually has two different ways you can create public URL endpoints from a serverless function. The first is something they call a web action. So when you're doing the whisk action create, there's a flag, --web, that you can set to true, which will turn this into what they call a web action, which means the platform will give you a unique URL for that particular serverless function that you can then call without any developer credentials. You'll get a unique URL that you can call. It'll invoke your serverless function and give you the result back as JSON, but now you don't need to worry about security and anything like that. And it's a really, really nice way. If you need a quick URL endpoint for like a webhook or a chatbot or something, this is a really nice way to be able to do that. Now, if you're kind of building bigger, more enterprise high traffic APIs, at this point you're probably thinking, okay, well, what about like API routing, right? I want to call different serverless functions based on different HTTP operations and methods and paths. What about rate limiting? I don't want people to call my services too much. Authentication. I want to be able to use it to be able to authenticate requests using something like OAuth. How do I manage deployments and all that kind of stuff? And if you're using web actions and you want to add in some of these features, you have to handle all of that in your code yourself, right? So you need to look at the HTTP headers and all that kind of stuff and manually code in all of those features. So obviously this isn't a very scalable approach, right? If you're building bigger, more high traffic APIs, you don't want to be manually adding all this stuff in every time. So what most people do, and this is the pattern for serverless development for kind of bigger APIs, is they use a third-party service called an API gateway. And what API gateways allow you to do is they allow you to provision public endpoints, public URLs, but then proxy private APIs in the background. And the API gateway will be able to manage all of those features for you. So they normally can do everything from rate limiting and paths and authentication. So they take care of all of that, and they're just going to call, using the platform API, your serverless functions whenever a valid request comes in. And all big cloud providers have API gateways. So IBM has one called API Connect. Amazon has one called API Gateway. Google acquired APACHE recently to do this exact same thing. So this is kind of pattern that people use for building bigger, more enterprise APIs, using serverless functions, use third-party API gateway services to manage all those features for you. So let's have a look at doing that now. Let's take my Bitcoin function and expose it as a public endpoint that then kind of anyone can call, turn it into a web action, and then finally using the API gateway. So if I go back to my terminal and then mirror my screens. So let's start with the web action, right? I just want to create a random unique URL for my serverless function that we can call. So I can say whisk action. I'm going to say update rather than create because it already exists. Update Bitcoin. I say --web true. So it goes, OK, now you're updated. Now what you do is you say retrieve Bitcoin and give me the URL. And it's going to give me back this kind of random URL on the platform. So now if I copy that, so I can say HTTP GET. Now I need to do it in curvatures. And I'm going to say I want some JSON back. So I use a concept JSON. And then you give the parameters just as query parameters, right? So say currency equals like US dollars. And hopefully, it should just give me back the same result, right? The same JSON that's been kind of encoded from the API, right? So there you go. Right now, you can see real HTTP endpoint. If your eyes are good enough, you could be calling that from your laptops now. And that's really easy to do. So web actions are a great way to turn a serverless function into a random URL endpoint that you can use for kind of things like webhooks and things you just need a quick API to be able to talk to. Now, imagine my Bitcoin API gets incredibly popular, and I need to worry about rate limiting and authentication, all that kind of stuff, because it's a very, very important API. So I want to turn on kind of API gateway integration. I want them to be able to manage that stuff. Now, OpenWhisk comes with an API gateway actually built into the platform, which is very, very nice. And you can just manage it through the command line. So you can say whisk API create, whisk API delete. But I think it makes a bit more sense. It's easier to understand if I show you it through the kind of web console on the cloud platform. So if I go back to, where am I? Where's Chrome? Oh, it's there. If I go back to Chrome, and this is just kind of the web management console for OpenWhisk when you run it on Bluemix. And I have the ability to say, OK, create me an API. And you can give it a name. So I'm going to call this one Bitcoin. And now you can see you can start to find things like paths. So I can say I'm going to create a new path called Bitcoin. It's going to be a get. It's going to call my function Bitcoin. So it'll do the routing for you. It's going to return me some JSON. That all looks good. And then you can see that you can toggle on all those features we talked about, right? So you can toggle on authentication with keys, with OAuth, rate limiting if you want to, call support to call it from your browser. And hopefully, when I click save, it's going to give me another URL endpoint, right? So this is completely separate from the kind of private platform API. So I can copy that now, but it should do exactly the same thing. So I can go and say HTTP GET. There's this random URL it's given me. That's fine. I'm going to call API Bitcoin. I'm going to say an amount. Let's do like loads. And currency equals US dollars. And hopefully it should do kind of exactly the same thing, right? It's just going to give me back the JSON having called my serverless function. But now I'm not exposing the platform API with my credentials or even using a web action. I'm using the API gateway, which gives you a lot nicer enterprise features. It's kind of the pattern we use in serverless development for building bigger APIs. OK. Cool. So all of the examples we've just been talking about, all the kind of use cases, have been around using serverless functions to build kind of APIs, right? Where you're going to want to call the function, you're going to block waiting response to come back, and you're going to do something with the kind of response of the JSON that comes back. But another big use case, another big kind of example they talk about for serverless cloud platforms is building event-driven applications or event-driven architectures where your functions, the platform is listening to an external event source like a message queue or a database or an object store, and whenever one of those external events occurs, the platform will automatically call your function for you. So you don't have to be listening to the message queue and then call the function using the client library. The platform's going to do that automatically. And this is another really, really big use case of serverless cloud platforms. So in OpenWhisk, the way that we handle this, building event-driven applications, is by creating something we call triggers within the system. And you can, using the command line, create triggers that listen to these external event sources. So when you create a trigger, you give it the name of the external event source, and whenever that event fires, so if you might listen to a message queue or a database, the trigger is going to fire in the system with the parameters of that particular event. And again, you just do this using the command line. So you say whisk trigger create, you give it a name to identify it, and then you have this flag, --feed, where you can pass in the identifier for the event source you want to listen to, and any parameters to be able to connect to it. Now, the event sources, all service platforms support event sources. It's one of the key parts of the architecture. But the types of event source are slightly different between each platform. So on OpenWhisk, these are the 6 that kind of come out of the box. So you have the ability to have your service functions be automatically invoked whenever there's new messages in Apache Kafka. Apache Kafka is a very scalable, open source, distributed message queue system. So you can kind of have them listening to that. There's an event source for CouchDB. So Couch is a NoSQL, very popular open source database. And whenever there's changes to the database, you can actually have the triggers fire within OpenWhisk. There's one for RSS feeds. There's one for mobile device events if you're running just on Bluemix. There's one for GitHub. And then another popular event source in serverless cloud platforms is the scheduler. So you can have your event source. You can set up an event that is called every 5 minutes, every hour, every day to set up, kick off some kind of automatic background processing, which is really nice. So when you've created your trigger in the system, which is listening to some external event source like a queue, using OpenWhisk, you can create rules which bind your actions, your serverless functions, to those triggers. So whenever the trigger fires with the event, it's going to automatically kick off your function, passing in the details of that message or that database updated process. And you can actually have multiple functions all listening to the same event source or the same trigger, which is a kind of really nice pattern. And again, in OpenWhisk, it's all just really easy. You just say whisk rule create. You give your rule a name. You give it the name of the action and the trigger, and then they're kind of bound together. So whenever message comes on a queue, trigger gets fired, and the platform will automatically kick off your serverless functions. So this is a really, really nice way for you to be able to start to build event-driven applications, right? Have your functions listening to some external event source, and you don't have to manage anything at all. So if you've been kind of following along over the past sort of half an hour, 33 minutes, haven't just been on Slack and things like that, which I know most of you probably are, hopefully you can see why I'm personally so excited about serverless cloud platforms, why I think they're such a step forward in developing software for the cloud. And maybe now you agree with me, right, that servers really kill your productivity, and you're all fired up to go back to your office and start setting fire to everything and just get rid of your servers forever. But before you do that, right, it's only fair of me to introduce you to some of the challenges of building microservices in the cloud using Swift, using serverless platforms today. Because like all technology choices, right, it comes with trade-offs, it comes with constraints, and serverless cloud definitely has some of those, right? It's still a very new and emerging space, and it's definitely got some rough edges that you have to be aware of. So I'm going to kind of talk about two challenges, one which is very specific to Swift, and one that's kind of more general. So the first challenge, and this is specifically affects the Swift runtime, is understanding the difference between what they call warm versus cold activations and the effects that can have on performance of your APIs. The first time we call a function on a serverless cloud platform, it's cold. They say it's cold, and then subsequent activations is called warm. Now, if you were, as I said, if you were really paying attention, you might have noticed this kind of pattern when I was doing some demos at the command line. That the first time, right, you create and run a serverless function, it's always a little bit slower than subsequent activations. Right? So in this very unscientific experiment I did when I was creating the talk, right, the first time I recreated the Bitcoin serverless function. It took about 4.5 seconds to run, and the second time it was around a second. And you might think, well, why is this, right? This wasn't due to some intermittent Wi-Fi issues or some bug in the platform. This is kind of characteristic of how serverless platforms work. But you might think, yeah, why? But why though, right? It's the same code executing in the same place on the same platform through the same method through the command line. Why should there be such a variation between the first invocation and subsequent? Well, to kind of explain this and help you understand, I'm going to need to show you a little bit of how serverless cloud platforms work under the covers to kind of help you understand how this affects the performance. So when you type whisk action invoke, a number of things have to happen before the actual, the JSON comes back from your serverless function. And at a high level, for the Swift runtimes, these are the steps. So the first thing the platform has to do is it actually does need an environment, right? It needs to create an environment to run your code in. And the way they all do this under the covers is they all just use Docker, right? So all serverless platforms just use Docker under the covers. It's Docker all the way down. And they create a new environment for you, which has the Swift runtime in. They inject your code from the database, which you created with a command line. They run the Swift build, and it runs a Swift build to produce the binary, calls main, and then it's going to serialize back the response of your function, which has to be stateless as the kind of result of the JSON from the API, right? And those steps are what has to happen before you get the JSON back, and they're the kind of cause of the delay from when you type the command to when you get the response. Now you'll notice that the last step on that list is pause container, right? Because what happens is rather than to improve performance for subsequent invocations, what we call warm invocations, rather than throwing that environment away, it just pauses it. It pauses the container, so the second time you invoke it, it doesn't need to, it just resumes the environment, doesn't need to inject the code, doesn't need to run Swift build because your binary is all available. So it can just call your stateless function again, passing in new event parameters, getting second event parameters out. And that's where there's a difference between the first time you call it and subsequent activations. And your environment will be reused for around 5 minutes. So if there's been no function call for 5 minutes, it does properly get rid of it, and it will be cold again. Now you might think, does this matter, right? Does this really matter to you, right? If you're building kind of event-driven application, maybe you're listening to messages on a queue, you just want to do some analytics and push it into a database, who cares, right? It takes a second, it takes 2 seconds, it's not really a problem. But if you're building very, very latency responsive APIs, you're building a chatbot, you want it to be as consistent as possible, as responsive as possible, this might be a bit of a problem for you. So what you can do is, there's a trick to kind of improve performance for cold invocations. And that is that you can run the Swift build locally, and then you can deploy the binary rather than the source code. And what that means is that during cold invocations, when it creates the environment, injects your code, it's not going to run the Swift build because it knows there's a binary already there. It's going to call your binary, passing in the event parameters. And actually, Swift build is not known for being super fast, right? So this is actually the source generally of most of the delay during cold activations. And then, again, this is a very unscientific experiment with like a tiny API. But you can see now cold activations is like 1.4 seconds. There's a much smaller difference between warm versus cold activations. And as I said, this particularly affects the Swift runtime because it needs to do that build step. JavaScript and things like that don't have such a difference between cold and warm times. But at least you're not Java. Java is terrible. Like the cold times are horrendous. So, okay, so that was one challenge, right? Let's look at a second challenge. The second challenge is around compute limits. And this is not specific to Swift. This is specific to serverless cloud platforms. Now, serverless cloud platforms they're very opinionated about the kind of microservices they expect on a kind of software, right? It's for modern cloud-native microservices designed to run and exploit the efficiencies of running in the public cloud, right? Built for stateless functions, all that kind of stuff. It's not designed for lifting and shifting legacy apps, right? Not that there's many legacy Swift apps out there, but it's good to be aware of. So they're really designed to run these modern cloud-native microservices. And one of the ways that they kind of enforce this constraint on you is by limiting access to a lot of your computational resources on the platform. So, for example, these are some of the kind of limits in the documentations about things, limits you have on the platform. But really, there's 2 big ones that you need to be aware of that most people run into when they're getting started with serverless development. The first is timeouts. So when you're processing a request, the serverless function has to finish processing that request and return in a maximum of 5 minutes, right? 5 minutes. And that is normally a hard limit on all the platforms. They all seem to have defaulted to a maximum of 5 minutes. So if your code does some super complex calculation that takes like an hour to compute, right? It's not going to be appropriate for running on a serverless cloud platform at the moment. And again, the other big limit people run into is the amount of memory. So you can change the max amount of memory that your function has available to it to allocate, and you get charged basically as a function of the amount of memory and the time that your code is running. So you can set a kind of maximum limit, or you can up how much is available to you. But normally that's in the order of like half a gigabyte, 2 gigabytes. You can't set it to allocate like a terabyte of RAM. So if you need to be able to do some super complex math that needs like terabytes of RAM to do really, really quickly, it's just not going to be appropriate at the moment, right? They're really designed to be running small stateless functions that kind of evoked in milliseconds. So it's important to know the limits of the platform and embrace it and build your architecture to support those, not to fight against it. And also realize that it's not appropriate for everything, right? If you do need things that need terabytes of RAM, that's fine. You can go and use Docker or traditional infrastructure. So I said at the start of this talk, right, that servers kill your productivity. And maybe now you agree with me, right, especially if you're thinking about doing back-end development, right? All that time you'd have to spend patching kernels and managing VMs and upgrading middleware is time that you're kind of not spending in Xcode writing Swift. It's just kind of maintenance that you suddenly have to do to run your code in the cloud. And I think as developers, it often feels, if you're doing back-end development, that you get held hostage by your servers, right? I want to spend my time over here writing Swift. I spend it logged into that horrible Linux terminal trying to fix some kind of kernel issue. So I want to kind of encourage everyone here, right? If you're thinking about getting started with back-end development in Swift, you're thinking about developing microservices for the cloud, using Swift, right? Embrace the serverless revolution, right? Burn your servers, deprovision the virtual machines, delete your containers, be free of the tyranny of looking after infrastructure forever. But more importantly, upgrade your productivity, right? Spend your time in Xcode, not actually managing all these kind of sprawling VM environments. So thank you very much for listening. I know that it's time for lunch, and I'm pretty hungry as well. If you want any resources from that talk, go to bit.ly, burn_your_servers, and you'll go to a GitHub repo with all the demo code in and everything you need to get started. If you want to know more about OpenWhisk, as all big open source projects do today, we have a Slack channel you can add for like the 100th time. Stack Overflow as well, where you'll probably get an answer from me. Or if you need help, just come and find me on Twitter @ThomasJ or @OpenWhisk, and then we can kind of help you get started with Swift without servers. So thank you very much. Questions?
Thank you very much.
Or we just go and have lunch?
Yeah, we'll start with the applause. Yeah, we'll start with the applause and then the questions. I will come to you guys. I found it pretty interesting that IBM is asking us to burn all the servers.
Yeah.
That's
pivoting, we're pivoting.
If you have to remember one thing of the conference, IBM told me I should burn my servers. Go to the IT and tell them that. Who was the first one? Whoever.
So I just burned all my servers. How do I save my user data?
Well, so that's a good question, right? Because people are like, well, what about my database, right? Still need user data. What happens with serverless development is I call it, you embrace the platform. So if you want a database, you want a cache, you want a message queue, you don't run and manage those bits of infrastructure yourself. You just use the provider's offering, right? So I'd use hosted Kafka, hosted Elasticsearch, hosted whatever backend database you want to use. So generally what people tend to do is that it means you can literally focus on writing just that core code that's relevant for you and your business, and you outsource everything else. I'm going to outsource the infrastructure. I'm going to just use a scalable database. There's like 1,000 on every cloud provider these days. So you use hosted offerings for everything, and you just focus on writing code. And that's one of the big advantages, just the agility of like, I'm going to focus on the code. I'm just going to use other services, and I'm not going to do any of that kind of maintenance or operations thing. So yeah. Obviously, you need stuff apart from code. You need loads of other services to talk to, and you generally just provision them and run those in the cloud. What you don't do is then like, well, I'll stand up a VM and I'll install MySQL, and then I can manage that, right? You just use a hosted MySQL.
We'll go this way around.
And my question is, when just imagine that you invoke all actions when it all ends, like after 5 minutes, it kills the server.
Yeah.
And when you imagine just invoking after just 5 minutes every time, does it pay off in the price range?
So prices. So there's a number of things. Kind of informally, I've seen lots of. You can go and read. There's loads of blogs about people talking about moving their workloads that are very good for serverless, and their bill at the end of the month was like 90% cheaper or 80% cheaper, right? Because especially when traffic is very variable, it's hard to predict. And there was actually there was a research paper recently by an analyst firm called 451 Research, who were looking at, they did an experiment and they tested different workloads on different cloud providers with VMs and containers and serverless, and they found across the board generally serverless was much cheaper. And actually the compute is incredibly cheap, right? So all the providers give you a massive free tier to get started with, and it's huge. Cloud Functions and IBM is the same, and it's just the compute is incredibly cheap compared. So it seems much cheaper to me to run your compute there than anything else, and you're only going to pay for the time you're working, right? So yes, I think it's super cheap. And also, I think, think if you're a small company or a startup, your costs scale linearly with the work that you do, right? So if you're suddenly your API gets super popular, that's fine. You're going to be making more money, so I can pay for more resource, right? If I never really grow, guess what? I don't pay. If you don't get any requests for a month, you're not going to pay for anything. Isn't that amazing?
Early on in one of the slides, you talked about receiving string to any and then returning string to any. Is that at all going to change with Swift 4 to be sort of string to JSON decodable or encodable or at all?
That's a good question. I'm waiting for the pull request from you to add that in. That's great feedback. I don't think there's any plans for it at the moment, but if that's definitely something I think when Swift 4 is kind of released, then they would definitely look at. So that's really, really good feedback. There's one at the back.
Can I use CorePods or Cartridge with it? So that I have third-party dependencies, or your functions look only so small?
Yeah. Obviously, I have to, just like make it so simple that it just works perfectly. So it's a good question. Obviously, so first thing, and just, I've introduced you to a lot today. I know that, and there's loads more stuff I could talk about. Obviously, you're going to be running in Linux containers using the open source Swift runtime. So obviously, Foundation isn't 100% complete, and then a lot of the libraries don't run on Linux. Almofire, you've got no chance. So you can't natively kind of just lift and shift any Swift code over. You do have to be a bit more aware about developing in Linux using Swift. You can use the Swift package manager, absolutely. If you've got a package that you can install and use with Swift package manager on Linux, you basically, yes, you can just build the binary locally with all that in and deploy it. The existing Swift runtime does actually come with 3 or 4 Swift libraries already available for you, like KituraNet, SwiftyJSON. So actually, if you're just doing JSON and KituraNet, you don't even have to compile it. You can still use it, and it's available in the runtime. But yeah, if you want to use other libraries, as long as it's supported on Linux, you just build the binary and ship the binary. So yeah. There's a question at the back.
Yeah, I go back to the back anyway. We have time. I mean, we are all hungry anyways.
So I'm an app developer, and I also sometimes do backend development with Ruby on Rails. Mm-hmm. And once I had an API that took like 350 milliseconds, and my fellows told me, "Wow, that's too slow. You can't keep it like that." Thus, I have the question. I know there's a warm mode, but it looked like it takes a second. Is there a hard mode that's even faster, or why is it 1 second?
Yeah. So that was, as I said, unscientific. That was me in the UK talking to a data center the other way around the world and all that kind of stuff. So yeah, it is pretty quick. It is pretty quick. And that's the round trip time. So that was like the time my Unix workstation was timing, right? One thing to note is you only get charged for the milliseconds your code is running, right? You don't get charged for the full second that it takes to get from my laptop to America and come back. But I'm using a data center in California because it's just where I've been doing it for a while. You can use different regions to be much closer to your customers and things like that. So I actually think Swift is a really interesting language for serverless because I think it's really, really fast, right? And what you really want actually is a language that is really, really quick because you're charged for milliseconds. So I think other languages which are kind of more dynamic and evaluated, there's more kind of overhead. So it's hard to give you fixed numbers without knowing more of the use cases. But I would say that big companies are using serverless for all kinds of different stuff, and they generally haven't seemed to kind of run into that challenge. I know. So Expedia, huge travel site. They do 1 billion AWS Lambda calls a month. Huge. It's all massive volumes basically. So people are using this today for like real production stuff. So yeah. So I wouldn't draw too much into that random screenshot I just did there when I was at home in my garden on my Wi-Fi.
Thanks.
There was some people in the back. Manu, at least. Hup.
So first of all, thanks for the talk and the insights. And I wondered, how does scaling work?
Yeah.
Are there any built-in methods which are used under the hood for me? And which possibilities do I have to manage it myself if I need it?
So in terms of scaling, your functions scale horizontally. So what happens is the platform just spins up another environment, another container, injects your code. So if you have say you get 1,000 requests in parallel at the same time, just get 1,000 runtimes in the background being spun up for you, and it just is automatic. So there is like a maximum limit of like 50,000 parallel invocations or something. But the scaling's not, as a developer, so your functions have to be stateless. They can't use application memory and all that kind of stuff. And if you make them stateless and you push all your state to the database, right, then the platform will then scale horizontally for you. So it's not something you implicitly control. It's just, you just get as many functions as you have requests being processed at that time. And sorry.
Can I limit the horizontal scaling with some quotas?
Yeah, so you can put limits in place to stop, because obviously you can scale infinitely, but then your credit card will set on fire because you're spend like $1 billion. So yeah, most of them allow you to put limits in place on activations and things like that, because eventually you run out of money. But hopefully you won't get to that. I mean, if you run out of money on serverless, then you're probably doing something wrong, because it is incredibly cheap, I think, for the compute layer. And I think my personal opinion is, having been involved in the cloud, 3 to 5 years, this will be the default way that you build software for the cloud. Containers are going to disappear under the covers, and this will be it for like 80% of use cases, right? There's still lots of restrictions. You can't get GPUs on it at the moment, and not all runtimes and things like that. But I really think this is the future, and I'm incredibly excited. And I think Swift is brilliant for you to be able to do it as well.
Right. Wait, I think. Whoops. Oh, sorry.
Sorry. Many serverless providers lack features when it comes to tracking down error situations. So you can do remote debugging, and you can do hot deployment and stuff like that. And mostly you have to put it in a zip file and upload it. And so how do you handle this situation in your case? Because when I have to build a Docker container locally to do debugging and stuff like that, there's no win for me in this situation.
So debugging is a moment, the kind of Achilles heel of serverless development, because all of the things you know how to do to SSH into the environment, to look through the logs, to look at system calls, you just can't do any of that, right? Because you have no access to the environment. So what are they kind of doing about it? I'd say that's one advantage actually of Apache, of using an open source cloud platform, of which Apache OpenWhisk is one, is that actually you can run the whole environment locally and just use it locally for testing and development, and then deploy it when you're ready for production. Lots of the providers have been really focused on building out better tooling at the moment. So Amazon has a new service called X-Ray for their cloud, which is around tracing. We've got similar capabilities. Microsoft have been doing loads of good work around tooling on Azure Functions. So this year, I think they're all really focused on the problem of making the developer experience. Because services, and one of my slides of challenges that I dropped out because I didn't really have enough time, is around debugging, because you're kind of much more reduced to logs, basically. You can still get logs out, standard error, stand out. So you need to have really good logs that you can turn on off with a feature flag, so that you can, if you get into a problem, and also your service functions are like you're running, you're doing distributed systems, right? You've got functions, calling other distributed systems and regions, and that stuff gets tough. So there is a big, not a big gap, but there's a gap that's being filled at the moment with different startups are looking at this, providing better tooling for serverless. It's a really busy space at the moment. But yeah, I mean, obviously, in some ways, unit testing is quite easy, because you can simulate the serverless function test harness really easy. You just call your function, you pass in some JSON, get some JSON out, right? So the unit testing is quite easy. The production testing is harder, because how do you simulate the full cloud environment, right, and different services? So there's still lots of unanswered questions, and I think there'll be much better tooling about this in the future. But yeah, you can run OpenWhisk locally, or actually, we publish the Docker images on Docker Hub for the runtime, so you can just pull the Docker image or run in, inject your code, and simulate being called through the platform. And that's an advantage of using an open source platform. With the proprietary ones, you can't do that, because they don't publish their Docker images. So yeah, there's not one answer for that, but there's a number of different things to kind of think about.
All right, who is still not angry enough that he still has a question, or she?
I mean, I'm going to be around all day, so
I'm calling this the last question, right?
Okay.
By the way, I just realized you like a lot fire. So.
Yeah. Secret pyromaniac. That's all it is. Just go around setting fire to servers all the time. Don't let me in your data center.
Is it right that one service can call another service?
Yeah.
You demonstrated this with Bitcoin.
Yeah,
So there's a possibility that one of my services can call one of my other services.
Yeah.
Maybe what are you doing about logs?
Like
infinitive calling each other, or could happen with a 3-stage service calling around, or recursions.
Yeah.
I actually don't know how you want to do recursions except with the URL going to another URL.
Yeah.
So you build this sort of URL stack. But this is possible. And what happens to your purse then?
Yeah. So your credit card company will call you and say you're about to spend like $1 million. Do you want to put no? I mean, obviously, in your code, normally your code could get into a loop and never come out of it, right?
Nice conditions.
So, right, and it's funny you should say that. There was a blog post last week, I think it was on Hacker News, talking about someone who'd done that thing. They'd have their serverless app, and they'd accidentally got in one function called one, and it just, and they spent like, well, the cloud provider was very nice and cancelled their bill, but it was like thousands of dollars before they realized. So you need to have proper monitoring, but it's your code you can have a bug in your code that, I guess the limit, limiting how much you can spend, and then monitoring, right? Having good tools so they show your usage and things like that, and good testing, integration testing. It's just your code. How do you stop your code getting into a loop?
Just imagine out of office service, you send him and it broadcasts, and somebody else is using the same service, broadcasting it too, and you got a ping pong. I really saw that on an email service, just ping ponging. I'm out of office because they actually did it at the almost same time.
Yeah, there are limits on the platforms in terms of how many parallel activations you have as well. Right? It's not infinite. It depends on the platform, but there are some limits. So if you can't just infinitely call it. Eventually, your platform has a fixed number that you will hit.
Okay, but it's possible, and it's easily possible if you do some stuff like that, like iterations and hierarchies. You can just run into just memory hog or something like that.
Yeah.
All right, so that's a whole good set of questions that we had, and for the other questions you can ask James during lunch. We have an hour now, something like an hour, and there's got to be a reason to get a ticket and not only follow the live stream. And the
food.
Yeah, well, not only food, but also being able to ask you furthermore questions.
The comedy. I think they're here for you, aren't they?
Yeah,
the MC, the wonderful MC experience.
Well, it's on live stream as well, except if you mean like hanging around with me or whatever. Yeah, you could mute it. Okay. What do you mean people are muting me? No, they would just put me on fire.
Yeah.
All right, so go outside, enjoy the food, and think about it that around like 10 to 2 or something like that, a few minutes before 2 p.m., I will shout so that everybody go outside to take the wonderful jumping pictures. And that's it. Round of applause for James again.